Hi everyone. Isosceles triangles is the topic we're working on. And if you recall, an isosceles triangle is a triangle that has two congruent sides. These two are the marked sides. Now the marked sides are called the legs. So that is a leg and that is a leg of an isosceles triangle. The angle between the two legs, the two congruent sides, is called the vertex angle. And this is a base angle as well as this. And as you can see, these two angles are congruent as well as these two sides. Now the Isosceles Triangle Theorem says if two sides of a triangle are congruent, then the angles opposite those sides are congruent. In other words, if it has two congruent sides, it's going to have two congruent angles. And what it means by the angles opposite the sides, this side is opposite this angle. This side is opposite this angle. If these two sides are congruent, these two angles are congruent. Let's look at this first example here. If segment DE, and that's this segment right here, is congruent to segment CD, which is this segment right here, BC, I'm going to put 2 marks in BC because I put 1 mark in these. These two are congruent. I don't want to put any other mark unless it's congruent. BC is congruent to AC, so these two with 2 marks are congruent to each other, but these two are not congruent. And the measure of angle CDE is 63 degrees. So I'm going to put 63 degrees in my drawing there. The question is, what is the measure of angle BAC? Well, what is this one going to be? All right. Let's go back to what we know from the theorem up here. If these two sides are congruent, then these two angles are congruent. Angle DCE and angle DEC are congruent. Angle C here, angle E here. I don't know them right now. I'm going to put an X here. But what I do know is X plus 63 is equal to 180 degrees. X plus X is 2X plus 63 is 180 degrees. I'm going to subtract 63. I have 2X equals 117, and I'm dividing by 2, and I'm getting X equal to, let's see, 50, that's the 100, 8.5. So X is 58.5. So this is 58.5 degrees here, and so is this angle here, 58.5 degrees. All right, well that's just from what we knew. And I see vertical angle right here. And that is also 58.5 degrees because vertical angles are congruent all the time. Now angle A down here, BAC, angle A down here and angle B are opposite congruent sides, so they are congruent angles. So I'll put 2 marks in each of those. And I don't know what they are, so I'm going to put Y here and Y here. And I do know, though, for the same reason, and I'm going to do the same thing I did up here, Y plus 58.5 is equal to 180. Y plus Y is 2Y. Just put those two together. And as soon as I find Y, we will know the missing angle that was asked for. So I'm going to subtract 58.5 from both sides. Minus 58.5 from that side. I got 2y here. Let's see. Let me put the 0 here. 10 minus 0 is 5. Borrowed from here, that's 7, and 10 is 9, minus 8 is 1. 7 minus 5 is 2. So 2y equals 121.5. And I'm going to divide both sides by 2. Y is going to be 60. And then half of 1.5 is, half of 120 is 60, half of 1.5 is 0.75. So the measure of angle BAC is 60.75 degrees. All right. That's using the fact that if the sides are opposite congruent, if the sides are opposite, the sides are congruent, let me try one more time, then the angles opposite them are congruent. That's using it. Okay, theorem 410. I said write the converse of the isosceles triangle theorem. The converse means flip it around. And on this side we said if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So let's write the converse of that. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. Well, let's look at our drawing here. The drawing says name two pairs of congruent angles. I do see angle PLM in this triangle right here is congruent to angle PML. That angle right there. These two are congruent. They were marked that way. Now I also see, though it's not marked, that these two angles are opposite congruent sides in triangle LMN. So, angle, that's a semicolon, by the way, angle MLN is congruent to angle MNL. So, two pairs of congruent angles. Two pairs of congruent sides. Well, what's marked? Segment ML is marked to be the same length as segment MN. In addition,
Chris Jackson to the Encore office. Chris Jackson to the Encore office.
And segment PM is congruent to segment PL because those guys are opposite these two marked angles. So that's using the converse. Last example, triangle EFG is an isosceles, is an equilateral triangle. Is equilateral, and EH bisects angle E. That means this angle and this angle are congruent because this big angle E was cut into two equal parts. We are to find the measure of angle 1, the measure of angle 2, and we'll find the value of x. Alright, so what do we know here? We know that if we have an equilateral triangle, that all three of those angles are 60 degrees. They all have to be the same. If the sides are all the same, the angles are all the same. So that's 60 degrees, that's 60 degrees. Angle E total is 60 degrees, and in two equal parts, it's 30 degrees. So angle 1 is 30 degrees. Angle 2 is 30 degrees. Okay, so let me look at triangle EFH so that we can focus on X here. If I figure out what that angle is, 60 plus 30 is 90. 180 minus 90 is 90. That's a right angle. So's that. So 15x equals 90. Solve for x. You get x equals 6. X equals 6. Okay. Take notes on that. We'll practice in class tomorrow, and I will see you later.